This is the review for Barrons practice exam number 1, also called a diagnostic exam. Here is the FRQ part. Again, whenever we work on FRQ part, try to read the code first, not to read the description, because it will take too much time. And then you figure out what function need to be worked on and what class and function are available. Then you go back to read those detailed description. Don't miss out some detailed stuff. Okay, now let's look at the FRQ one. The FRQ one, this one actually is a array utility, and this one actually is testing you about how you can construct a static method. So this one basically just need to be able to reverse the array. And for reversing of the array, we talked about that before. So basically, if you have this original array, you just need to swap these two and these two. And the middle point, you don't need to take care of it. And the middle value, this middle value actually can be calculated as what? As length divided by 2. Right? Midpoint has 2 ways to calculate it. First way to do it is mid by 2. Length divided by 2. The second way to do it is actually equals low plus high and then divided by 2. And low plus high divided by 2 is actually 0 plus length minus 1 divided by 2. So actually these two slightly different. The first way to do it actually is what? The division, after the division, the midpoint will belong to the lower half. Let me see. It will belong to the upper half, sorry. And the second way, the midpoint will belong to the lower half. Okay, that's the only difference we have right here. So we will look into this index problem when we review the binary search and what merge sort. Okay, now let's get started for this problem. So basically, it's a traverse and swap algorithm, but just traverse through the array halfway. And the middle point, you actually, if it is an odd number, you don't even need to swap the midpoint. So it actually is just a traverse from I equals 0 up to less than midway, less than the length divided by 2. Don't even touch the midpoint. If you touch, it's okay because actually it's the same. It's the same. It's for odd number. It's the same number, same value. So now, basically, this reverse array, we just need to get the ID from 0 to halfway, and then we do swapping. So this one is easy. Now the second problem, part B, it actually is a matrix, and this matrix is 2D, and we have the reverse row, and part C we have let me see. We have the reverse O row and the reverse matrix. Reverse O rows is for part B, and reverse matrix is for part C. So basically, this one actually is the reverse O rows. So each row you swap. Let me use the highlighter. So for each row, you actually swap this, and it will become something like this. This is so-called swap O rows. But you do it row by row to the bottom. So actually, you need to call the previous function utility, the utility function. But the name is called array utility, and then reverse array. So let's move back to the previous one. So basically, you need to call this function reverse array. But because they belong to different class, so basically you need to be able to call it using array dot using the array dot reverse array function So you need to be able to do this, that reverse array. Okay, but you need to be able to call it in the class method. This is not instant method using the class method. So that's the key point you can do. But if you actually miss this one, and you didn't it doesn't you don't use this class method way of calling it, and you write whatever swap inside reverse all rows, it should be fine. But it will depend. It depends. If the problem description they say that you have to use that function, then you may get 1 point deduction, but will not be a major deduction. And if you copy the same algorithm from A, most of the time the grader won't actually take your point away. If you just exactly copy the same code from A, they know that you know it, and they won't deduct your point. But the better way is actually using have that metric class to use the array utility class that reverse array. So the nature of the problem is each row itself is an array itself. So you need to know about the knowledge. The row itself can be an array, but column you cannot assume column is an array. It actually, a matrix is organized as an array of arrays. So each of the row item is actually one element in the matrix array. So now, now we just need to do this to reverse all of the rows. So this one actually is not hard. And then part C now you need to actually do a complete reverse. You reverse the whole matrix. So the point is, you need a reverse row and reverse column. So reverse all row part, you actually just call the reverse all row. So each row you will reverse this. So actually these two are by that. And then you need to reverse column. But when you do reverse column, there is no function you can call. So the only way you can do is actually do column major traversal. That means you traverse through the array like this, and then like this. Okay, but also because it's a reverse of an array, so actually you also do it halfway, not completely. So halfway means you reverse through the array, but actually you swap this and this. So that becomes this and this in the column. But because you already swapped the row, so you become something like the right hand side. So let's move on to the next page. So basically you need to reverse all rows first. So all the cells in the row will be swapped. So you call reverse all rows. So part B call part A, and then this part C need to call part B. Then you perform a column major traversal to swap the cell in the column. So basically you call this reverse all rows first. Okay, so here it has a question. Do we need to put mapped dot something here or no? Do we need to put mapped? I'm sorry, I should use a bolder. Mapped dot reverse or no? If you put a map dot reverse, will it work or not? And also, it is required or not? Okay, I post this as an answer. So basically, no map dot something will be fine, right? But if you write a map dot reverse all rows, will it work or not? Christopher, like he's not alive. Okay, no problem. Let me clean this and move up. Okay, right here. The answer is no. You shouldn't put that math because math is a data field for matrix, right? But math is actually integer array. So it is not a class. No, it is not a class. It's an array of integers. Since it is not a class, so this reverse all rows does not belong to the math. No, it is not. Okay. It belongs to a matrix.
Okay.
So actually, we are calling this that reverse all rows. Not work on this math. But it's not math that reverse, because math itself is an integer array. It doesn't have the method you want to have. Okay, so that's the key point for this one. Other than that, this one is not really that hard. So you have column major, so you put column as the outer row. And then inside there is you put a column as a outer row. And then inside there, you actually in the column, in the same J, you send J in the same column. You put J in here, it's okay. Then you swap this one to the first one. Okay, so when you swap, actually it's like this one is I, and then this one is n minus 1 minus I. Right?
Yeah.
When this is 0, this one is n minus 1 minus 0 is n minus 1. So you swap something like that, and then you also traverse halfway. It will be done nicely. Okay, now let's move on to problem 2. Here has some testing result. I think it's okay. I don't want to waste time to do this. FRQ2. This FRQ2 is a text editing program using the sentence class to manipulate the single sentence. So we have get blank positions. We need to implement this one. So we got a sentence, and then we need to figure out where are the blank positions, and then put them into an array list. And in fact, it returns as a list integer type. And second one, we count the number of words, and that's part B. And then third one, we get the words. Since we count it, we can also get words. So this problem actually is only traverse through your array or traverse your through your counter. So it is not really hard. So let's look at the sentence. This one is the class. This class actually I summarize, take out all the precondition, whatever text and comments. It actually is a very tiny class, just like this. But anyway, let's get started from there. So part A, you need to find out the blank positions. So basically, you ask, when you take exam, there is some example like this. You try to figure out that actually using the example that here are location you want to find out. And for Y, there is no space. And also, we will go back to read the precondition. Actually, no blank. If there's no blank, you need to return an empty list. Okay, and then you need to figure out where contain a blank in the sentence. Okay, now this part is not hard. So basically traverse through an array and add the index of spaces into the array list. So this one's actually easy. You create a new array list. This is a must. Okay, this one is a must. This one is a must. This one is a must because when you actually finish, you cannot cross out this. You cannot cross out this and put a semicolon. It won't work because if you do that, you will have the value of null. Then you return null. Null is not an empty array list. So you still need to construct this. There is an object, but the size is 0. But if you put null is a pointer address value, but there is no object associated with it. So that's the only part you need to be careful. If you put this one, it won't work. Put a semicolon, it won't work. That's only thing you need to be careful. Second, for here, I equals 0 and then I less than sentence dot length, I increase. This one, we just take a single character string to compare with space. So I and I plus 1 is actually only one single character I. And I plus 1 is not included. So if these two are equal, we add that I into array list. So this part is also easy for part A. Now let's look at part B. Part B is actually want to return count how many words. I'm sorry. It want you to return count how many words. So a quick way to look at it is actually, I know my location for space is 2, right? Two numbers. Okay. So I just use 2 plus 1 to get this 3. So basically, you have the previous one, and this one actually you just have the 5 plus 1, you get 6. And this one is 0. There's no space, so there's 1 word. That's the simplest way to do this. So the way to do it in the simplest way would be right here. You generate that array list. You return that A list, right? And that A list actually being stored in here. Actually, it is returned. So you basically just need to call that function. So you call the get blank position, and then plus 1, then you will get whatever you want to have. Okay, but here I present a different version. You know, so here is you need to determine the word's ending location, and then basically these are the ending location and the end of the array. The end of the sentence. There is also another ending, but that one has no space. So I put an array mark. So you need to plus this one in. But my algorithm, the example I give, I know that we have the simple way of doing it, but my sentence here, my answer here is try to avoid if there is double space or triple space. So my solution worked, but it is a little bit more complicated. So I get the location for the blank position, but this blank position may include if you have double space in between those words. So if you have those character, for example, right here you have 2 space instead of 1, or here you have 3 space. Those situations, even though the problem statement doesn't mention about this, but if you don't take care of it, it's okay. But in my example solution, I would like to take care of it. So the way to take care of it is, I still look at the space location. If my space location is 0, right? That 0 will not be counted. That means that my sentence has the leading space over there. So that one should be counted. Okay. Second, and then if I'm a space, al.get I is a space, and then the previous one is also a space. A space left by a non-space later is the end of the word. So if it is the previous one is a space, then I don't count it as well. Otherwise, anything in the array list is considered is the beginning of the. Is the end of the word. You know, 2 conditions. The leading space is not a end of a word, and also if a space have a space in front of it, then that space is also not a space, not the end of the word. Okay, and if you are the end of the sentence, and then your previous one is not a space, then we consider that is actually the end of the word. So by doing this, I can correctly count the number of the words. But this is a little bit more complicated. Number 3, we want to get all the words out. So this part, the solution given by Barrons' book is very wordy, very complicated. I think it's not a good solution. My solution is better. You have this black mark as the end of the words, right?
Mm-hmm.
And I just want you to add a -1 as the beginning of a word, a red one as the end of the word. So the two number I add in is actually -1 and this one len, not -1. len -1 is this period. So what this will work is I have the space that leading my word, and I have the one that after my words. So by doing this, I can get out my word by what? By substring. This -1 plus 1. And this one put here. Okay, this 1 plus 1 would be the starting of the string here. This one is already the end of the substring here. Then I can get a word. So for the next one, here, same thing, I need to plus 1. That would be location kept. And then I put this mark over here. It's the end of the word, but not included in the word. Same thing, keep doing that. The first one, I will got a word here. Second one, I got a word here. Third, I got a word here. I continue. I call this black one and red one and blue one as spacer. It's just like you put a chopstick between two meatballs or something. You have the spacer in there. So actually, in front of first meatball, you also put a spacer, and in the end, you also put a spacer. And by using two spacer, you can get out a word. Using two spacer, you get out a word. So I can systematically get out all the word I have. So my algorithm, by doing this, would be easier. Let's look at the algorithm. So basically, I do the same thing, get black position. And so this AL, I have all of the black arrow, right? And then I prepare a word list. This one is an empty word list. This one is prepared for the addition of those words. Now, I add a -1 in 0 location of this AL. So basically, this -1 is the blue mark, blue arrow being added. And this AL that add sentence that length. This one is the red arrow. Suppose the blue arrow and red arrow are added. Now, I started to traverse through the array to get the beginning of the string and ending of the string. So my blue mark need to +1. This one is the beginning of the string. My blue mark is -1. Sorry. My blue mark is -1. So I need to +1 to get 0. This is the beginning of here. So this one, black one, I need to +1 to get here. This +1 to get here. But the end, I just use this one as the end of the word. This one is the end of the word. This one is the end of the word. This one is the end of the word. Something like that. Okay? So by adding the blue mark and the red mark, actually, I have systematic way of doing it. I just traverse through the array, and then array list, I'm sorry. And each time I get a starting mark, I get a starting mark already and the ending mark for blue and red arrow. So I get a beginning and the end, and then I put here to cut the word out of the sentence and add that word into the empty word list. And the word list is an accumulator. Keep adding different words in there. After I finish, I have an array list, but the data type I need to return is a string array. Now, I use the word list size to create an array of strings. Then, one by one, I copy it over. So this finished part just want to get a easy string of array of string out. And there's a question: why don't I, in the first place, put an array over here? Because I'm not sure how long it will be. Yeah. Actually, you can use that, maybe the get this al.length plus 1, maybe. But in case of there's something wrong, so this is actually safer. This one is actually safer. And also this algorithm is pretty and very I would say concise. The core part is very tiny. Okay, the core part is very tiny. Just you need to know about the concept of spacer, using a spacer to separate data. So here I have a sentence: I love you, and then this and this. I get a blank position, so that's a part A. And then I count words, counting words, it works. And then part C, I actually get out all the words, and then it's in an array, and I convert it to string. It would be like this. Okay. Now, question 3. Question 3, we have a player, and that has the get player number, and also there's a tournament. Okay, it's really much like a registration for a Taekwondo tournament. So I think this one is familiar for us here. So player is an array of slots, is an array of players. So if certain slot number slot is assigned as null, then there is no player being assigned to that slot. But if there is some player in there with a player object, then that one is occupied. So then there is a wait list if the number of players is actually full for all the slots. But in this tournament, there is no tell of how long this slot should be. Assuming that we have a constructor and we know that is of certain size. Okay, there is no tell of, because the whole class, it doesn't tell us where this how long this slot is. But anyway, in this case, we need to assume that there is a constructor that will give us the initialization of this slot size. Okay, so and then we need to work on the request slot and also cancel and reassign this slot for a player. Okay, anyway, the beginning part is like, okay, I try to create something for the player. Because I want to simulate it. Without this, it won't work. So I assume that there's a name and player number to create a player, and then get player number. For a tournament, I put these two methods, but temporarily I put null over there. We need to develop that. And I also know that there is a constructor I need to do, but in the exam, you don't need to do that. You just need to finish this, and assuming that there's a constructor and slot as the instantiation. So part A, we want to request a slot. So to request a slot, we actually they provide us the string for player's name, and then the nature of the problem is actually it's a linear search to locate the first empty slot, and then we assign the player name and the ID and insert the player in that slot. And then we return the player. If not found, if there is no null at all, then we return null. That means that there is no player being created. And also, in that case, we actually will put that player into a wait list. Because you request it for a slot, but there's no slot for you, so it will be added into the wait list. So the idea is not too hard. It is also a linear traversal. So the name get given, and then we start it from I equals 0, and then I less than the slot length. And then if it is null, okay, then if there is a certain index I, it is null, then actually we can create a player and use that I as our index, as the player's ID. and then assign that new player to that start and return that start and get out. So we don't care about it if there's a start for it. If no, if we traverse the whole array and no, then we add the name into the wait list and return null. So this part A is not hard. It's just a traversal of the linear search of an array. Part B, we need to cancel and release a start. So this one actually will be given a player object. So a certain player object being assigned here, and this player will be taken out from the start. And then if the wait list is empty, then we will just take that player out of the start. But if there is some people in the wait list, then we will get one guy from the wait list, remove one guy from the wait list, and then put that one guy and create a player object and add into that start that been left out by this player P. Okay, so the nature of the problem again is a linear search. We need to locate the player that requests the cancel. We need to locate that player's slot, and then if not found, that means that this player not even is a legal player in the tournament. So then we return null. There is nothing to be done. If found, that means that the player need to be kicked out of the tournament. Okay, he cancel anyway. Pick up the first waiting list player to replace this current player. Remove the first waiting list player from wait list and replace the start I. And then return the first player to first waiting list player. If no wait list member, then we just make the start empty and return null. So the problem is not really too hard. We started from I equals 0 and traverse through the whole start. And then if the player is equal, so here you need to equal. Let's don't use a double equal sign. Equals the start's player. Then we need to try. If the wait is not empty, then I get the name is a string. So this one is another person is actually a string. We use that string as a name and the current I because P is going to be kicked out, so the ID will be given to this Q player. So Q player being created and then add into the start. And if the wait list is actually empty, then we reset that start to be null, waiting for other people to come in. And then we return null because there is no player occupying this start I. And if everything goes through and actually there's actually no, this player has no match at all. That means this player is not even in the list. But this condition actually is not described in the problem description. But you need to figure out there is some case like this need to be handled. Otherwise, what will happen? In the compiler, you will forget about this return may not exist. You will have certain case have no return and compiler will complain. But in the exam, whether the reader can read so much detail or not, I don't know.
Okay.
Maybe got this deduction, maybe no.
Oh, okay.
So here is the test case. Okay, I have a sequence of 18 player in and then doing something. Okay, first I create a tournament. So the tournament I define it by myself. I create a tournament constructor using the capacity of certain number. But this is not given by the problem description. But I want to write a program, so I put the capacity there. So the start number is actually to be 6. Okay, and then I put every time same jump into there. So 4 player, the last 2 will be empty. Now I print this initially the national. National is the start allocation. Okay. Now I have Eric sign out and then actually will get from waitlist for X, right? But at this time I do not put anyone into waitlist because the start is not even full. So in this case, what? This first guy being kicked out, but no one from in the waitlist. So no one being filled into here. Okay, that's reasonable. Then we actually have Aiden. Okay, we add an Aiden in, and Aiden will take this stuff. But no waitlist as well. Now, and then we have the Barrons, Caret, Delta, and Fanny B, C, D, F going in. And the national will be with this, and okay, waitlist, and 2 people go in. Now, I actually cancel C, Caret being taken out. So Caret being taken out, Delta being removed from the waitlist and inserted into the slot. So this shows you my program work perfectly with the assumptions. Now, problem 4. Problem 4, we have a chemical solution. It's said to be acid. Okay, and there's a pH value or anything. Now, we have an interface solution, and this interface solution has no data field. It only has the get pH and then set pH. Okay, this one is a solution with 2 methods. And then it says that, okay, there is a certain mechanical arm that will actually test the pH value, whatever, and there is an experiment. Now keep going on. There is an interface mechanical arm, so now we got 2 interfaces. And then this mechanical arm has a get current index, is facing right, move forward, 3 measure, 4 measure, there's a change direction as well. Totally 4 measure in mechanical arm. Both are interface, so we have no way of figuring out what's going on here because there's no data. We haven't seen the object yet. Now, the next one is experiment, and this experiment holding the mechanical arm and also holding a solution list. Okay, now we know. Now we know that the data structure is actually presenting the list is for this, and the arm is a reader on this. Okay, but this question is a little bit tough for students because it's hard to figure out what's going on. And this class experiment has a reset and a most acidic. So this one is trying to find the lowest pH value, and there's a reset. But well, one class, this one not even implement the arm and mechanical arm and solution. So it actually has a relationship. But you have a mechanical arm, but this mechanical arm is an interface, and solution is again an interface. So the problem we have right here is that this arm is an object, but we know mechanical arm is an interface. An interface cannot be instantiated. That means this arm needs to be instantiated by a certain object that actually is implementing mechanical arm. Also, the solutions themselves is a list of solutions, but these solutions are not solution because solution is only an interface. So there should be some sort of a class that implement this solution, and those can be added into this list of solutions. So this problem is similar to APFRQ 2011. This one is similar to that, and it creates trouble. People don't know how to do it. And this time, I have that 2011. I mentioned in our someday review. I told you that problem is tough. And here, this time, I'm trying to stick with the interface and believe that all the methods are well designed. And the problem has been modified. So this one actually makes more sense. The Barrons version makes more sense. But still, it's still very abstract. Not easy to comprehend that what's going on. So there is one assumption nobody can understand is that the machine can only be traversed. The experiment of the traversal can only be traversed by mechanical arm. And what this really means, I will explain this later. But first, you need to be able to figure out that the relationship for this whole thing is, so basically in the exam, you need to be able to figure out such a chart. The solution is the interface. You won't be able to instantiate. So there should be a class called solution bottle or solution something, but holds some solution with the pH value. Also, the mechanical arm is not a object or a class. So you need to be able to figure out there should be some arm that implement this mechanical arm. So the method being taken over to arm, and the method for solution also being taken to solution bottle. And this arm is trying to read the solution bottle's value. And then these two are organized as an experiment. And then there's a data set to test this experiment. So there's also, again, one more missing link. This problem we want to do, part A, experiment has a reset, but reset for what? It's a reset function. It actually was trying to reset the arm for this this experiment. So it should be reset to this. So basically, the head need to be returned to 0, and then the direction need to move to front. So basically, if you go back to read the class, the interface. You have these methods that you can use. You have the get current index, you have the phase in right, and then you have change direction, you have move forward. And in this experiment, you have that reset. So reset, need to reset this arm using those 4 methods given by arm. And this arm, you need to be able to know that it is not an interface to operate. It's this arm to operate. So this arm must have some implementation that actually implement those 4 methods for you. Now, you need to use that 4 methods no matter what they are. So you basically need to read this carefully, these 4 methods carefully, and then figure out how to reset your method. But there's one assumption: the problem is not given, and also the previous 2011 exam, that similar problem also not mentioned. It is this: the nature of the problem, reset to the initial condition, but it doesn't tell you this is not an array. There is no random access. You can only use the arm with that 4 method, and it only has forward, backward, and advance few steps. Only these 3 functions. So it's just like you play a tab. You can only say that's play, or that's pause, or that's return. These are the only functions you have. So basically, it's not like memory or not like an array. Okay, I want to get I, get 4, get 7. There's no such thing as get 4, get 7. You can only do forward, backward, move 3 step, or pause, something like that. You look the problem set. You look into that arms description. I'm sorry. Let's go back to the arms description. This arm, you only can get current condition, and you need to know I'm forward or backward. This one actually forward or backward. And change direction is to change my direction, either forward or backward, and then move forward or for a few steps. If you are facing right, you are moving forward. If you are facing left, you are moving backward. So with this in mind, let's go back to the reset function. The reset, for example, I'm at 4. Now I'm facing left. Okay, facing left is okay because I'm going to here. So facing left, I should be able to know that it's 4 minus 0. So I move forward 4 steps, I'll go here. So basically, you know your index, and then you know your 0. So you actually move 4 steps, your index number you should be able to get here. Right? And then you need to change direction, facing left to facing right. Now, if here you are not facing left, you are facing right. So the first thing you need to do, because you are going to here, you need to change direction first. Change direction, and again, using that index 4, come to here, and then face right. and you will be facing this way. Now let's look at the code. So basically, this is just like a tape, you know. You're kind of winding it or rewinding it, but there's nothing like, oh, okay, let's go to location 200. That is not, it is not a random access device. So the reset function, you need to check first. My arm is facing right or left. With facing right, I'm forward. Facing left, I'm backward. But this one, I'm resetting. I need to face backward first. So if I'm facing right, I need to change my direction to face left. And then I move forward my arm. If I know my current arm location, actually my location is the number of the step I need to move, because I'm moving that I'm going to 0. So this guarantee I'm going back to 0. After I arrive at 0, now I need to change my direction to the right, because that's the reset condition. That's the reset condition that this problem want you to have. Okay, but anyway, this one is better written compared to the 2011 one. And then let's look at the part C. This one, part C. Part C actually, let's go back. Okay, part B, I'm sorry. Part B actually is to find the most acid, right? To find the most acid, basically is what? Is a single traversal to find the maximum, right? Minimum, I'm sorry. The most acid one, the lowest pH value. So the first thing I need to do is reset my reading arm to 0, right? If I want to figure out what's the longest song in my tape, I have to rewind everything, right? Starting from the starting location, then I play it, and I will know, oh, okay, the third song is the longest. But I need to play the whole tape before I figure out that song 3 is the longest. The same thing here. I need to reset my reading arm to 0 and face it this way. And then every time I advance one step, get a value, and then actually compare with the minimum. So this actually is a simple finding minimum algorithm, but with non-random access feature. So let's look at so it's a finding minimum with play, pause, and rewind. And let's look at the solution. So basically, I need to reset my reading head. After that, if my size is equals 0, then I return -1. Okay, there is nothing, no bottle in my experiment. Now, the next one, I set my minimum to 15. Okay, the maximum, the pH value is 14, so I set 15. Okay, you can use the integer that mean value. Okay, that's fine. But here I put 15, that's good enough. Then my mean index I set to -1. This one useless. It will be replaced anyway. So now I get started. I equals 0, I less than solution, whatever, and then I increase, right? Because I reset already, so this actually is what? It's just to perform I times solution dot size times. This one is not really use I as index at all. Because what? Because we need to use the reading head. We cannot use I, it's not random access. So now, solution that get, the solutions is a list, right? So I'm trying to get current index that bottle, and then get that bottle's pH reading. If that pH reading is less than minimum pH, then I give my current bottle number and assign to mean index, and also I get my current pH reading to minimum pH reading. And after that, my arm move over for one step. And totally, I need to do solutions that size time. So this one is a single advance. So this is just like I++. Okay, arm that move forward is just like I++. And each time I use that reading arm to get one bottle and read its pH value out, and then compare with the minimum pH. And at the end, I will find a mean index because I have a reading. So here is not actually using the reading head. Actually, you already measure the data out. So I'm just reading from a table that I copy from this reading and then get pH value and then return to the, as the result. So the key point right here is to understand this this condition. If we have the head, that head can only operate in this way. Okay, and then the final result, if you look at the my test, it's just simple. I create the example from the description, and then I assign the bottles like this. And each time I read those value and set those bottles. So basically here just prepare the data. After that, I actually I try to print the existing pH value, and then I try to find its minimum. That's it. So basically here is a tester. And next one, actually, I want to print up that 2011 problem. Let's have some comparison. Let's jump to the Q3. Okay, Q3. This one is the fuel depot, and then there's a fuel tank. So the fuel tank is like the bottle, the solution bottle in the solution in the previous problem, and there's a get fuel level, and that one is get pH. Okay, anyway, and here is a fuel level, and then in an array or something. Now, second one, the interface robot. Robot is actually equal to arm. Also a full function. Get current index is facing, change direction, and move forward. So this actually is exactly the same problem. And then this one, fuel table, it has that arm. It's a fuel robot now. And then it also has that tank. That's the solutions. So the two problems are exactly the same. And both of them are also using interfaces. And then two functions need to be done. One is to find the next tank to be filled, and then to move to the locations. But this one is worse designed because there's no saying that I cannot random access the array or array list. Apparently, the data actually is array list. It should be allowing the random access. But here it said like next tank to be filled. Next tank to be filled is what? Actually, it's trying to find the lowest fuel level that you want to fill it. But I'm located here. I can search right or search left or search two circles to find a minimum. But which way should I do? There's no define. So this one doesn't ask you to do reset. So basically, you can. I'm just going right now. Nothing happened. I'm going back, and then I go back. That's the way I do it. Okay.
Oh.
So look at the solution I provide in this here, the APA. Actually, let's take. So basically, I'm trying to traverse through the tank and get fuel level, and then if there is certain value less than that, then I actually will be return that value and find the minimum one. Okay, and actually I traverse through array. But here I think I make a mistake on this next tank to fill. The reason is I actually do not follow the random access rule. I'm sorry, the non-random access rule. I'm actually assuming that I'm starting from the beginning, but there is no such things as reset in this function, and it is not assumed. Even other solution book also provide a wrong solution on this. But after reading that Barrons solution, I know that this one is actually wrong. But they also know reset function right here. Okay, the next one is to move the location, to move move the head to certain location. So it's a linear traversal with change of direction to find the location index. Again, it's not well designed. There's these functions, but they are not given. I can guess and I can write whatever I want. And both are interface, but they don't have the class. So I even don't know what's the implementation. So basically, I assume that, okay, if I continue traverse through my tank twice, I'm moving right and not, I'm going back and then going right. If I totally traverse the whole tank by two times, I should be able to find it. And in the middle, if I actually make a wrong touch the wall, the last or the first element, then I will change its direction. But in this move to location, I don't see how to do that. So I put that change direction in the move forward. But move forward actually is a function in the field robot. But it's not, there is no saying like, okay, you cannot implement that over there. So I put it here. But when I read actually this one, after I read the description, the solution by Skynet, okay, I figure out, okay, actually there's a change direction to do. But this one actually is also not the best solution because it actually don't know. It actually don't know the reset concept. It's just like, I'm going, if my location is above me, then I go to the bigger one. Or if it's less than me, then I face that one. But remember, this is a robot. You don't know the location index is greater than or less than you. Because you are single, you are single. The only thing you can know is facing left or facing right. So the definition or the requirement for this problem statement is not actually clear. This one is actually not clear, but I would say the problem description on the Barrons practice will be better. Okay, now actually we finished the FRQ.